Hello my dear friends, colleagues and students. On the behalf of ASSMS IOIT ENTC department, again I welcomes you all in today's session where we are going to cover our next tutorial assignment based on mesh analysis. In our last session we have covered our tutorial assignment based on node analysis. Now we will go for the mesh analysis. So problem statement for this mesh analysis is determine the current flowing through each loop or mesh by using mesh analysis method. So here we have to find out current flowing through various branches from the given circuit, and also we have to verify the results on using appropriate simulator on www.falstat.com. So before going to start, we required some prerequisite about this mesh analysis, where we need some definitions. What is meant by loop current? It is the current which simultaneously links with all the branches defining a particular loop. Okay, suppose if you have taken example of this circuit, then I1, I2 and I3 are nothing but the loop currents which are simultaneously links with all the branches defining a particular loop. Next, what is meant by branch current? The total branch current is the algebraic sum of all the loop currents associated with that branch. Example, for the branch current for 1 ohm resistance is nothing but the total branch current is the algebraic sum of all the loop currents associated with that branch. So here you can say that I1 minus I2 is nothing but the branch current for 1 ohm resistance as shown in figure, and similarly for 2 ohm also you can mention the branch current is nothing but I1 minus I3. Similarly, if you want to find out the branch current for 3 ohm resistance, it is simply I2 minus I3. So in this way we can define the branch current. Next, what is meant by loop analysis? Now loop analysis is a method where we have to find out the number of loops equations, and we have to solve that equation simultaneously. This method is useful for the circuits that have many nodes and loops. The difference between the Kirchhoff's law and loop analysis is, in loop analysis, instead of branch current we consider the loop current for writing the equations. In this method, if any branch carries more than one current, then the algebraic or then the total current must be decided by algebraic sum of all currents through that branch, which we have discussed just before. Now assume the loop currents such that each element of the network will be included at least once in any one of the loop. That means according to this diagram you have to write the loop equation which shows that every element should be covered either in one loop. So in this way you have to define different loops, then you have to find or you have to write the different equations for that loops, and you have to solve that simultaneous equation to find out the current flowing through each element or each branch. Similarly, the most important is how many number of equations we have to write. So here we can say that for mesh analysis, number of equations should equal to the number of loops. That means according to this diagram, if there are 3 loops we can define, then 3 equations we have to write and we have to solve that 3 simultaneous equations. Next, what is meant by super mesh? Super mesh is an additional concept when if there exists a current source in any one of the branch of network, then loop cannot be defined through current source, as loop across the current source is unknown. From KVL point of view, such a mesh is called as super mesh. Okay, so according to our this figure, we know that 7 ampere current source is present in between loop 1 and loop 3. That means this is an example of super mesh. So here we have to solve for this super mesh, where we have to find out the 3 mesh currents in the given circuit below. So according to the procedure, first define the current loops as we have defined, then we have to write the KVL equation for each loop. So KVL equation for loop 1, minus 7 plus 1 ohm inside the bracket I1 minus I2 plus V is nothing but that voltage across that current source, plus 2 inside the bracket I1 minus I3. In this way you can write the KVL for 1 or mesh 1, mesh 2 and mesh 3. After writing these KVL equations, we come across a super mesh where that 7 ampere current source is in common between loop 1 and loop 3. So here we have to write an additional equation for the super mesh by without considering this branch 7 ampere and 2 ohm. So only for this mesh or super mesh we have to write the equation. So that equation includes minus 7 plus 1 inside the bracket I1 minus I2 plus 3 inside the bracket I3 minus I2 plus 1 inside I3 and will complete equal to 0. Okay, so this is the super mesh equation. Now after solving these three equations, that means super mesh equation and another two equations for two different meshes, we get the final answer of I1 is equal to 9 ampere, I2 is equal to 2.5 ampere and I3 is equal to 2 ampere. So this is the simplest method to find out the current flowing through each branch or each loop. Okay, so once you define I1, I2 and I3, then you can calculate the current flowing through any branch or voltage across any branch, or you know that the current flowing through any loop you can easily define. Now this is after performing all the calculations, we get the answer I1 is equal to 9 ampere, I2 is equal to 2.5 ampere and I3 is equal to 2 ampere. So theoretically we are getting all the values. Now we have to cross check these answers by implementing the same circuit on fallstat.com. Okay, now we'll move towards this fallstat.com circuit simulator applet available on fallstat.com where we have to cross check these our answers. Okay, now we have to implement the same circuit over here. So in this circuit 5 resistances are present. So I have to add resistances according to their position. 5 resistances I have to plot. Okay, so I'll implement these 5 resistances. 3, then fourth one is at this position and fifth one is at this position. Yes, now press escape. We required one voltage source. So again draw input and sources. We required one DC voltage source, 2 terminal. So I have to draw this one at this position. Again press escape, and when we required current source. Okay, so again draw input and sources and current source we have to add in circuit. So current source in downward direction. Okay, so I'll complete this in this way. Okay, now press escape and complete the circuit by adding wires. So simply you can complete the circuit in this way. When your circuit connections are correct, then the color of the circuit will, you can see it becomes green. So first of all we'll complete the circuit, then we'll set the values. Okay, I did one mistake over here, so delete this particular branch. Okay, delete this one. I have to add wire over here. Might be these connections are wrong, so just we'll recheck. Okay, in this way we have completed the circuit. Now we have to set its value. So voltage source is of 7 volt DC, so just make the change, apply OK. Then this resistance of 1 ohm, not 1k, so 1 ohm, apply OK. This current source is of 7 ampere, again apply OK. Then this is of 2 ohm, not 1k, it is 2 ohm, apply, okay. This is of 3 ohm, 3 ohm, apply, okay. And the last one is, this is 2 ohm, value of resistance is 2 ohm, and last one is 1 ohm. Okay, so apply, okay. Now in this way we have completed the circuit diagram, and now we have to cross check the final answers. So current flowing through this branch is nothing but I1. Now you can say this I1 answer at the right side corner 9 ampere, which is exactly correct. Now the current flowing through this branch is nothing but the I2. It is 2.5 ampere, again it is exactly same. And the last one, current flowing through this 1 ohm resistance is nothing but the I3, which is again a 2 ampere current. Okay, so you can cross check these values, 9 ampere, 2.5 ampere and 2 ampere. So this is all about our today's session, where we can say that whatever theoretical calculations we have done by using mesh analysis, we are getting same results after completing or after implementing the same circuit on circuit simulator applet. Thank you all.